So, can sharks actually fly? No, they can't, at least without any special equipment, because they're aquatic creatures. But can I somehow make this shark fly? In this video, I'll find a way to make it do so, one way or another, or else. Since this shark is an inanimate object, it can't steer or propel itself, even if I give it basic wings and some monster, and therefore it just falls to the ground when thrown. So I came up with an inefficient and modular design which should work well enough and be as easy as possible to build. To build this plane, I used some closed cell XPS insulation foam, which is durable, lightweight and easy to cut into shape. To cut out the exact airfoil shapes, I set up my hot wire CNC cutter and cut out all the wing segments with it. This machine isn't the best one, and I'm planning to completely redesign and rebuild it at some point, but the results are quite good nonetheless, and it gets the job done for now. I also added control surfaces and cut out the hole in the middle of the wing where the mount will go. I glued these sections together with hot glue, which melts the foam together, and then trimmed the trailing edge smooth and cut out some holes where the servo motors will go. To connect the wings together and join the entire structure, I printed this part which goes into those holes which I cut out in the wings. This should be strong enough to endure the stress exerted onto it while flying. The tail is mounted on these brackets, which should also be strong enough, hopefully. If not, then it will crash. This plane won't have a traditional fuselage, and it also needs to be strong, so I decided to mount everything on these aluminum square tubes, which are really stiff and reasonably lightweight. To house all of the electronics and battery, I constructed this box out of foam and balsa wood, which slides onto there. As the flight controller, I'm using an F4 V3S along with this GPS. Soldering everything together was really tedious, as these boards are meant for quadcopters and such, but I had to use it in a fixed wing configuration. Eventually, I somehow got everything to work. I used this basic 25mW all-in-one analog system for basic FPV video, as well as the CLRS receiver. As the motor, I'm using a 2836 1100 kV motor, along with this 30A PSC and an 8040 propeller. I glued the motor mount to the frame with 2-part epoxy. I then mounted all of the electronics inside of the box before installing the servo motors and attaching them to the control surfaces. I also used some carbon fiber rods and balsa sheet to reinforce the underside of the wings. Just for fun, I also decided to add some landing gear so I can take off from the ground. And most importantly, I needed to somehow install the shark onto the plane. I secured it in place with this string, and hopefully it won't come loose midair. And now the build is ready. It turned out quite nice. So I came out here to the middle of farmland, because here's a road and I needed a runway. There's a bit of traffic, so I'll need to be careful about that. But yeah, let's get everything set up. Okay, here we go. It won't take off. Okay, I'll have to abort. Okay, it won't take off. It doesn't have the power. Oh! Because it couldn't take off from the ground and the landing gear was so heavy, I decided to remove them and instead try hand launching it. And because the shark and the lid acted like air brakes, I secured them in place much better this time. 2, 1. So that didn't go too well. The propeller seems to have broken, but everything else seems to be fine. I think I'll change the propeller now and try again. Luckily I brought a replacement propeller. This time I'll try to run and throw it, and maybe get some more speed at the start. 1. Oh no, go fly, no. It just doesn't have the power to take off. I hope it isn't badly broken. Oh no, the goddamn propeller is broken. I guess I'll have to head home. So, it flew, but it needs more power, so I decided to add the motor to each wing to more than double the thrust, which should do the trick. So I added some motor mounts. These 2212 motors are technically meant for 3S voltage, and because I'm using a 4S battery pack and 9045 props, I had to limit the throttle a bit to not burn the motors. These motors also provide extra lift from the airflow going under the wings, which helps with takeoff. They also enable differential thrust steering, which improves handling. Okay, let's see if this works. God damn it! This didn't work at all. The two motors just made it way worse. I guess the answer to the question of whether sharks can fly or not is that they can, but just not with a piece of shit like this. But most importantly, he's alright. After the crash, I realized I had made a huge mistake. I didn't take into account that whereas normal wings have a certain center of lift and mass, which perfectly balance the negative pitch moment at a certain static margin, with the tail providing a downforce to keep the thing in level flight, just as this plane did in the second test, and it would have kept flying had it had enough power. But the giant propellers and motors made them blown wings, which get far more lift at low speeds, but the center of lift migrates backwards, which means that the tail's downforce isn't enough to counteract the huge amount of negative pitch moment caused by the huge increase in static margin, which leads to a violent nosedive and crash, just as we saw with this plane. Overall, I wouldn't call this project a failure, as the shark did fly, though only for 50 meters or so, and I learned something new that I hadn't ever even considered before. I hope you enjoyed this video, be sure to subscribe if you wanna see more, and have a good one!